I'm the only one who bites, which is why they keep me on the stage. Hello, everyone. Great to see all of you here. A lot of familiar faces, a lot of people who I've been talking to somebody last night, and it's like, yeah, do you remember we met at RDC 2015? And like, yeah, it was really fun, a long journey. Good party last night. Shame I didn't get to play table tennis, but next year. So let's get this started. This is a talk, Lua as fast as possible. And we'll talk about the Lua performance, the work we have been doing, the work you guys can be doing on your scripts, and in general, how to reason about the performance of your Lua code. So yeah, I'm Arseny. You may know me, ZuxG. This is how you pronounce it. Let's get on with this. So we'll talk about the script profiling and optimization. What tools do we have? How should you work with them? And then the new Lua VM, which we will unveil the official name for the new Lua VM for the first time. How should you think about the performance of your code, and a case study. There's another case study in bonus slides. Oh, by the way, the slides are going to be available for download, and in general, this is recorded, so you will be able to refer to all of this later. I gave a talk about performance last year, and there's the fundamental rule that you have to keep in mind. You have to measure the performance when you're working on performance. You can't just blindly optimize things. The thing to start with, I guess, is should you even care about the script performance? And for some of you, you might not. If you don't have a lot of script code that's running, maybe performance is not a big problem for you. But if you have a lot of complex client-side scripts, or maybe you're building a game with 100 players and like 100 vehicles, and there's a vehicle script, and there's some player logic on the server, all of this takes time, and there's a lot of Lua code that you have to write. So the faster that Lua code runs, the better it is. Some of the things that I will talk about may push you a bit into the micro-optimization category, where you're trying to squeeze the every last cycle of your Lua code, and sometimes it's important, but keep in mind you should write code that actually works, and then you should make it fast. And for the rest of the talk, we will assume you want things to be really fast, and then you can make your own judgment as to how in-depth and crazy you want to be in terms of optimizations. The general optimization process is very simple. You measure the code's performance. You try to figure out what parts of the code are slow and why. You try to optimize them, and you rinse and repeat, right? Measuring is important because you can make a lot of assumptions. I will talk about some things that have changed in the new VM, where you can have a certain mental model about performance from the old days, and it doesn't necessarily apply exactly these days, right? So measure everything, but it's still important to ask what tools do you use for this, and also how do you change code so that it's actually faster. So let's dive into the tools a bit. I am sure you guys are all familiar with all of this, but let's reiterate. So there's the script performance tab. There's like kind of two versions of this. There's the widget in Studio, and there's the version of that in Dev Console. And this is a tool that we have had forever. It tells you for each script how often does it run, how much time does it take, and based on this, you can try to figure out which scripts in your game are slow. The nice thing about this is it works on the server, it works on the client, it works in Studio. So this is what you use to have a general sense of, okay, should I optimize any scripts? Maybe all of your scripts take barely any time at all. And if I do have to optimize scripts, which scripts should I focus on first? Once you know what script to target, the question is, what do you do then? Well, microprofile, I have been told that we lack good documentation on microprofile, and I'm sorry, this is probably my fault, but the tool is there, the tool is available. Not everybody knows, so I will reiterate this. You can get this profile information on the client and on the server. You can use Developer Console to get server-side profiles. So it will show you two things. One is for each script, it will show you how long does the script take in like milliseconds, but also what kind of Roblox API calls does it make, and maybe they are slow. It could be the case that your script takes 10 milliseconds, but this is because it does 100 raycasts, and each raycast takes a millisecond because your scene is really, really, really complex, as an extreme example, right? And in that case, you shouldn't optimize the Lua code performance in terms of micromanaging the instructions that you use. You should think about, can I reduce the amount of recasts, right? And the other thing is we have debug.profile, begin, end. You can use them in your code. They're documented on DevHub, and they will help you segment sections of your code and say, okay, in the vehicle script, I'm doing raycast, and then I'm doing some state machine transition logic, and then I'm updating my constraints with the new parameters. And for each one of those, you will know how much time it takes. Oh, and it's available on mobile as well. It's basically available everywhere. So you should really, if performance is important to you, you should try to master microprofile because it will help you in the long run. All right, grand reveal. Our new VM is called Luau. I already forgot what the name means. Like there's a meaning for this word, which is like a Hawaiian, I forget, celebration or something like this. But this is not why it's called like this. So it's complicated. Anyway, we are calling Luau all of the work that we are doing on Lua, which includes the VM, and this includes the type system that Adam touched on in his keynote. So the very simple explanation is your code will run faster. But this is not what we are here for, right? We are here to hear the details. So what did we do? Well, we wrote a new VM. I just had a conversation, and I was asked, why did we do this? Was performance really the key driver? And the answer is yes, performance was the only driver. Developers write increasingly more Lua code. We write increasingly more Lua code in our app, in Studio, in built-in plugins, etc. And then we are doing these massive servers where if you have any Lua code on the server transfer each player, now you have to run it 100 times or 200 times if you have 100 or 200 players. So if you don't write any Lua code, your game doesn't function, right? So the only driver behind the new VM was performance. And we used to optimize the cost of reflection, what we call, when the Lua code calls some Roblox APIs. But turns out this is not where the problems lie anymore, or rather this is not the only place where the problems lie. There's also the raw performance of Lua code if you have a voxel generator, or if you have a custom IK system or a custom animation system. You have to do some math, you have to do some table accesses. All of this takes time, and it can take more time than everything else. We are crazy, so we wrote a new VM from scratch. Here's what this means. So there's a new compiler which takes your source code, compiles it to bytecode. There's a new bytecode. It's completely incompatible with the old one. There's a new interpreter, which is much faster, and I'll talk about this in a bit. The big thing that we haven't fully finished, but we are working on this now, is the new zero overhead debugger. What used to be the case is in Studio, if you don't disable the debugger, your scripts run slower. And this is really inconvenient when you're trying to work on performance of your game, because you have to disable the debugger to get accurate measurements. Then you have to re-enable the debugger if you want to actually debug your code. All of this is not great. So in the new VM, there's basically going to be no cost to keeping the debugger enabled. And there's a bunch of other optimizations. But we didn't rewrite everything. So all of your scripts should still compile and should still work, plus or minus a few tiny caveats where people have been using things they should never have been using in the first place. We didn't really touch the standard library, which means that things like table.insert or table.sort, they didn't become magically faster. The internal implementation is still the same. But your code will get faster. And also for people who are into compilers, we don't have just-in-time compilation yet. It's something we want to do in the future. It's a key enabler of some really deep performance optimizations, but we can't deploy this on all of the platforms yet, so we are starting with like a much faster interpreter. What should you expect from the new VM? So everything that I'm going to talk about is basically if your code is limited performance-wise in the VM itself. So it's not the case, as I mentioned, that you have a lot of raycasts and raycasts are slow. It's like the actual Lua code execution is slow. So the general expectations is that if you have heavy code, we are seeing up to 2 to 3x gains across basically all platforms, client, server, etc. Studio as well. In Studio, there's an extra nice benefit, which I mentioned, where the debugger is zero overhead. So if you have debugger enabled, you could get like 5-7x improvements, because in the old world, the debugger had an overhead, plus the VM was slower. We didn't just optimize Lua code, we also took this time. Like once you take the VM itself and make it much faster, you're really forced to squeeze the every last bit of performance of everything else. So we had reflection code in our system that handles Roblox method property, Roblox method calls and Roblox property access. And we thought it was pretty fast because we optimized this a bit before. Turns out once you optimize the VM, this is now the bottleneck, so we optimized that as well. But if you're doing 100 raycasts, please do fewer than 100 raycasts, and then your code will be faster. How did we develop this? Well, so we had a few benchmarks that we grabbed from various places. There are a mix. There is some code that we have written before, like terrain generator. I see Stickmaster Luke is in the audience. He wrote the generator. Then a version of that is in our code. In our benchmarking suite, we have ROACT, which is our UI library. We have some other benchmarks, and we have some more, primitive, like basic micro benchmarks. How long does iteration take? How long does object-oriented programming constructs take? And as you see, we are seeing significant benefits across the board. I think these timings are from the server side. The actual gain will vary based on the platform. Like we see significant gains on Android, slightly less significant gains on iOS, things like that. So what's the status? There is a developer forum post on this where it's live in Studio as a beta option. So if you are a beta user, you can enable the VM in Studio, and you should. And you should make sure that the game works, because if it doesn't, you should talk to us, and you should tell us, hey, your VM has a bug. Because the expectation is you don't have to change code. The code should still work. We actually shipped it in Roblox mobile app. If you are using Roblox on iOS or Android, the application portion, like the thing before you play the game, it's actually written in Lua. Some people don't know that, or most of this is written in Lua. And that is also running the new VM. This doesn't impact you directly, but there's like 8 or it's probably like 10 megabytes of Lua code at this point. That's like a very real world code, which is to say the new VM isn't like a prototype. It works, right? It works on real world code. We have asked some people, hey, do you want us to enable this for your game? And some people graciously agreed, and so it's live for a few top games. If you want it to be enabled, there's like a developer forum post on this. And we will be, Adam promised in the keynote that it will be completely live in a couple of weeks. And I think he was slightly too hasty with that, but we will see about that. So our goal is to enable this globally soon, right? Soon as in this year, not soon TM, which is who knows when. All right, so the new VM is good and fast, but it's not sufficient. If you want to push the boundaries, it's not sufficient for you to just have our VM be faster. You want to try to make sure that your code is fast. And so it's really, really, really important to look at the code and to have a mental model in your mind, to have a picture of, OK, I think these things are slow and these things are fast, and then I can optimize them. If you don't do this, you're kind of working blindly, especially because we don't have a very good profiler that goes into like line-by-line depth. And it's way faster for you to optimize code if you know what things can be fast and what things can be slow. Even if you're off, this is where the measurement part comes in. Like you thought something is slow and you optimized it and it's still slow. Your script is still slow. OK, maybe this was not the problem. But you can build this mental model up as you optimize and optimize and optimize, as you gain more experience. The convenient way to think about this is to split the things that you could do in Lua into tiers. So let's talk about this. Ironically, this starts from 0, even though things in Lua start from 1. But the tier 0 is what we call primitives, which is things that the VM can do directly without talking to Roblox code, without doing C calls. It's basically roughly corresponds to what instructions are available in the VM. So it's things like local variable access, which is not surprising. Things like basic arithmetics, other operators that might not be arithmetics, right? But there are some things that are different about the new VM. So for example, computing the globals, like if you say math.pi or math.square root, or computing your own globals, like if you just have a global variable, it used to be substantially slower in the old VM for complicated reasons, and now it's substantially faster for complicated reasons that I mentioned. Array access is fast. Table access, if you have a local table like a Lua object and you just say npc.health, this is also substantially faster now, which is also counterintuitive because table accesses used to be slow. So now some table accesses are fast. So this is surprising, right? But we did this for a couple of reasons. One is there's a lot of code that does this. There's a lot of code, of course, that uses stable accesses and global accesses. The other reason is you're tempted to work around this slowness by localizing everything that you could possibly have. Like if you have foo.x, OK, put it in a local variable if you use it more than once. And it's fine. It still probably makes your code slightly faster, but it's not as necessary as it used to be anymore, and your code can get shorter. So we have a couple of interesting optimizations that kind of enable this new level of performance for these accesses. For the globals, we have this thing that we call imports, where we can say, OK, math.square root, we kind of know what this is, so we will give you the math.square root without actually having to look it up. And this is where the whole getFnv, setFnv stuff hurts us, because once you do that, we don't know anymore. So please don't use getIfEnv, setIfEnv. But the other thing is that if you have an object and you have a field on it, like as I was saying, npc.health, we are not doing a table access anymore. We are predicting where exactly in the table the .health will go. And then we are looking this up directly from that slot in the table. And then we are fixing up our bytecode if the prediction was off. So we now have like self-modifying bytecode. But the upshot is things are faster. So things are faster, and faster is good. So next year is calls. Broadly speaking, this is things that the VM cannot do directly by itself. It's things that it has to reach out to other subsystems to do. So it's things like calling a C function from the standard library, right? So I was mentioning table.insert. It's a call, right? So it's slightly slower than not doing a call. Calling a Lua function. We don't do inlining yet. We plan to do this. We don't do this yet. So if you have your own local function, it'll take us a bit of time to call that. If you have custom underscore index functions, or underscore new index, where we have to call a function and the function looks at the name of the key, this is also slower. We don't really recommend doing these things. And of course, if you have a Roblox built-in type and you are doing something like part.density is deprecated. Is there a non-deprecated? Part.name, so if you're doing like part.name, right, this is effectively a call through our reflection layer. So not all calls are created equal. There is some kind of hierarchy to that. Built-in calls to built-in functions are generally speaking faster. In fact, these are the current slides as the state is on production right now. I was just finishing an optimization last week that will go in soon, where the real built-ins like math.square-root and like everything from math, a bunch of things from other built-in tables will get about 2 times faster. So this will say probably 10 nanoseconds instead of 20. But this is the general state, right? You can see these are in the same ballpark, but some calls are slightly slower, sometimes some calls are slightly faster. All right, the next tier is allocations. So allocation is when you have to create an object, and then Lua has to manage the lifetime of this object. So there's the obvious things like you create a table, right, and there is garbage collection, and it has to keep track of this all. You can create a function, and it's also an allocation. There are a few things that are not obvious. So for example, if you have 2 vector3 objects, and then you add them together, like A plus B, what actually happens is we create a new object, but it's a full-fledged object. It has like a meta table. It's a bit complicated. And this costs you time. This is why sometimes if you do the vector operations yourself, not using the vector3 class, it can get faster, although we are going to change this for vector3 specifically in a few months. I'm not sure when exactly this will happen. But vector3 math will become faster. But as a general rule of thumb, like if you're doing C-frame operations, they might be expensive because they have to create new objects. And I'll talk a bit about closures later. So how does allocation cost manifest? Well, so you have to allocate the object, so that makes sense. You have to create it. And then at some point, you have to destroy it. But the thing that also happens is Lua has a garbage collection system that will traverse all of the objects in your level repeatedly and incrementally to try to figure out, are you still using this? Maybe you're not using that. Maybe I can free up some memory. And so it used to be that you had no visibility into this. A few months ago, we shipped a feature for this where in microprofiler, there's now these bars that I'm not sure if it's like readable, but it says GC incremental, and it's slightly reddish, which is not a good color. And this means basically probably your script is doing a substantial amount of allocations, and then the garbage collection activates and says, well, I'm scared that I will run out of memory. Let me try to do some work. We are planning to improve some of these things in the future, but this is the current state. And instance manipulation, I think this is kind of like everybody knows this. At this point, if you change properties, you might incur expensive things that happen. Like if you move the part, you are starting to ask the physics system to resolve some collisions. And I will not go too much into that. There is a forum post from a while back where instance.new with the parent property is specifically problematic for a couple of reasons. But this is roughly the usual. So let's do a case study on how do you apply this knowledge, right? So like that some operations are faster, some are slower. OK, how does this help? So let's look at object-oriented programming. Everybody does this. but also everybody does this in their own way, because Lua doesn't have a first-class support for this, which we hope to fix at some point in the future. So there's kind of two dominant approaches, closures and metatables, and I will compare them directly, and maybe this will help understand kind of how to reason about code's performance. So for people who are in the back, I hope your eyesight is good, but for people who are in the front, here's an example of an NPC class that has health points and max health points, and you can get health points, and then you can damage or heal, I guess. You're a positive company, so you don't damage things, you heal them. This is what it looks like with closures, right? So you have function objects inside a function, you have local variables that correspond to fields of your class. So what's wrong with this code? Well, if there's external code that needs to operate with this NPC, there's no fields that are exposed from this NPC, which is good because it's encapsulation, but it's bad because, for example, you have to know how many health points are left. You have to call a function getHP, right? As we learned, calls are slow, so that's not great. But I want to focus a bit on the creation aspect, which is particularly interesting here. And so what happens when you have to create a new NPC? And for NPC, maybe it's not as important, but if you have a class for a bullet, then maybe you have tens and hundreds of thousands of them over the lifetime of your game, or over a short duration. One thing is obvious, we have to create the object itself, like the table, right? Local self. There's a couple of things that are less obvious. One is, oh, actually, I think these slides are slightly wrong because there's probably 7 allocations here, not 5, but whatever, we'll talk about this in a bit. You have to create new function objects. We can't cache the self.heal function in a meaningful way because it has to reference the fields of the object. So you have to create 2 functions, but also you have to, what in Lua's terms is called close and up value, which means that if you have a local variable that is defined outside of your function, if any function accesses this at all, there was going to be an allocation for this specific variable. And in this case, we have 2 fields, max HP and HP, and for each there is 1 allocation. So if this is inefficient, we had a very, very simple object, and we ended up with 5, and what I actually think is 7 allocations. So this will hurt the creation time, and this will also increase the garbage collection overhead. So what do we do about that? Well, there's a a different way to do this, which is metatables, which I think probably a lot of people use metatables instead of closures, but let's look at a simple basic example, right? So you don't have to declare the functions inside the function anymore, and you have fields that are just fields on the object itself, so you can say self.hp. If you have an NPC handle outside of this code, you can say npc.hp, this all works. And you have to set the metatable on the newly created object so that we can find the methods, so that you can say npc : heal, and it will call the right function. So direct access to fields is good. You can now say npc.hp, and it will be fast. There's just one table, which is good for some complicated performance reasons. But let's take a very close look at the creation process. First, we have 2 individual assignments to the table fields. And this is what I haven't told you about yet, but this can be expensive. And the second is we create a new meta table for each new object, even though they're all the same. So the meta table part is straightforward. We can just put the __ index on the class variable. But the field allocation is slightly interesting and slightly complicated. So as you see in this example, instead of creating an empty table and then assigning 2 individual fields to it, we just create a table and we immediately tell our VM that, hey, there's going to be 2 fields on this, max HP and HP, they have these individual initial values. And so this is faster. This is faster because even in the old Lua VM, when you assign a new field to a table, it sometimes has to reallocate the table, and this can be expensive. And this is especially expensive for small tables. But the other thing is that our VM now does an optimization that's called templated tables, table templates, whatever. It's inspired by what Luigi does, which is if we have a table with the known keys ahead of time, like this, where it's like max HP and HP, when you create it, we don't create a table and fill it with keys. We have kind of a prototype of a table, and then we copy it, clone it, and then we fill it with values. And this is much more efficient. There's some kind of basic, simple micro benchmarks on the slide. So this is how you would apply knowledge about performance tiers, right? You look at your code, you say, okay, I think these things are slow, I think these things are slow, but I think this thing is like catastrophically slow. Okay, let me try to fix this, let me measure the code again. Okay, the code got better, cool, let's do this again and again and again, up until either you're satisfied with the performance of your code, or you're kind of scared of the resulting code and how hard it's gonna be to maintain, and then at some point you stop, right? You can never finish optimizing code, you can just stop doing this, so at some point you stop doing that. All right, so let's talk about some things that we have talked about and some things that we have not talked about yet. And then we will have time for questions, which is slightly different from my usual presentation where I talk for 45 minutes and then, nobody can ask anything. So you might care about performance. Especially if you have large games, complicated games, et cetera, et cetera. Measurement is super, super important. Don't do optimizations blindly just because somebody like Arseny told me that tables are slow, so I'm not going to be using tables. No, don't do that. Arseny told me that tables are slow, so I will measure the time my code takes, I will try to fix this, I will measure my code again, and if I get good wins, I will do that, and if I don't, I will blame Arseny for being wrong. So this is the model you should follow. NewVM is wonderful. It's one of the very exciting projects that we have worked on, very, very deeply involved and technical, and it's going to make your code faster, which is good. And there's two other important things that I think would help us and also would help you that I don't see happen too much. So one is if you have code that is slow and you think the code doesn't have to be slow, but you don't know why the code is slow, there's two things you have to do. One is talk about this on dev forum. A lot of people have a lot of experience writing scripts. Some people are diving deep into like micro optimizations and they know what things are slow, what are fast. Some people don't, right? So ask help from your peers. But also, send examples of this if they seem just completely wrong, like I'm doing some really, really basic thing, and it's taking a lot of time, and then I can do the same thing in like a different language outside of Roblox, and it's much faster, like why? Well, send these examples to us because the way the performance work on the VM is done is we look at actual examples of as real-world code as we can manage, try to understand why it's slow, and trying to understand can we improve the VM to make it faster, right? We have had some community contributions. We have a couple of custom humanoids, humanoid systems running in the benchmark suite. We have at least one more terrain generator that does things a bit differently from our current one and hits a bit of a different kind of stress points. But so if you have code that you think should be fast and isn't, if you don't know how to make it faster, send it to us. Maybe we can help. We are not done. We are just starting. We have a really, really good foundation now with the new VM, but the performance work on the VM is going to continue. So there's going to be more improvements, static typing, Adam talked about that, and just-in-time compilation. We really want to do this. One thing that I'm really excited about, because basically almost nobody in the world has done a thing like that, is that multi-threading is important. If you run on the server especially, you have a 100-player game, you have 100 humanoids, or sorry, not humanoids, but like let's say you have 100 custom humanoids, custom NPCs, custom logic. There's a single core, there's so much you can do in a single core. But the problem is how do we enable multi-threading in a way that is A, reasonably easy to understand, like it should be reasonably easy to program, right? B, safe. And by safe, I mean specifically if you can crash our engine by causing a race condition between multiple threads, it's a bug in our engine. It's never your fault. But with multi-threading, this is really, really hard to establish this kind of guarantee. So we think we have a design for multi-threading in Lua. It's going to work a bit differently from how normally Lua works. But if it does work, you might be able to write your code in the way that you can get advantage from multiple threads of execution. We are like super not ready with this because we don't have a prototype yet, but we have, I think, a thing that will work. So if it doesn't work, we'll have to regroup. But if it does work, it's going to be really, really good. And classes, who cares? Metatables are cool, right? Before we go into questions, so as I mentioned, the slides are going to be up for download. There is a couple of links that I have gathered. There's like general Lua performance guidelines that to a large extent still apply to Roblox. There's a couple of specific tips. There are good threads on dev forum about them. You should check out the thread about the beta of the new VM in Studio. Try it on your game, et cetera, et cetera. And we kind of want to expand in the future the coverage of performance-oriented articles. You could imagine that maybe the same talk, but instead of like half an hour of information, it's like 2 hours of information, and it's in an article, and it's on DevHub. And if you really want this, tell us that you want this, and maybe we can do this. And there's a bonus case study that we will not have time to dig in, but there is some code in the case study where, hey, how do you compute the bounding box for a bunch of parts? And there's a couple of different methods for this, and there are some performance guidelines there that summarize, not summarize, they combine the micro optimizations that we have talked about, like what things are slow and low, what things are fast. Some more macro optimizations, like sometimes you can restructure math to just take less effort to compute because there's less math to compute. Check it out. I will not spoil this.